Hi, welcome back to another video. And in this video, we're going to learn how to solve quadratic equations. All right, so let's go ahead and begin. Let me go ahead and put on my drawing app. Okay, there we go. Okay, so it says use factoring to solve the following, to solve the quadratic equation. So we're going to go ahead and start off by attempting to factor. So go ahead and write x squared minus x minus 56 equals 0. And we want to see if this is factorable. Go ahead and start by making your two parentheses like so. And, go ahead and put your x's in front so you can get your x squared when you go ahead and FOIL, when you distribute, right? All right, now, what I like to do is I like to determine your signs. And in order to determine your signs, you're going to want to look at your C term. So remember you have ax squared plus bx plus c, and I guess you could put equals 0. So remember, this is the standard form for quadratic equations. So look at your C term. If your C term here is a plus, that means that both of these signs in here, they both have to be the same. Whereas if you have your C term as a minus instead, like so if you have ax squared plus bx minus c, automatically your signs, like in this case, is going to be plus and minus. So it can either be two pluses, two minuses. Perhaps we'll have another example in the future. If not, I'll make you one. Let's go ahead and see if we can go ahead and finish factoring this thing. Okay, so we need factors of 56 that when you subtract them will give you a -1. So we can put a -1 there. So what are all the factors of 56? Well, I have a video on finding factors. It was my first video ever created. You should go ahead and check it out. It's pretty thorough. You can skip around. I put chapters in that video as well. Okay, so we have 56 times 1. That's the very first factor. And let's do our technique. So divide by 2, multiply by 2, divide by 2, multiply by 2, divide by 2, multiply by 2. And 7 can't be broken down, so we go over to the 8 and do the same thing, divide by 2. You're going to get 4 again, right? If you were to divide the 8 by 2. Since we get our factor again, that's it. So which one do we use? We have to subtract them in order to get a -1. Which one of these, when you subtract them, would give you a -1? It has to be 7 and 8, right? Okay, we know 7 and 8 is going to make a 1, but which one goes where? Well, looking at the equation, we have a negative in the middle. So, you ever heard the expression, the bigger number takes the sign? Of course you did. Of course you have. So the bigger number here, the bigger factor is going to be 8, and the smaller factor is 7. So, everything is nice and factored up. So we factored everything, and we're ready to go ahead and put this as our answer. So let's go ahead and type in x plus 7, open parentheses, x minus 8, close it up, hit enter, and it says good job. Of course it does. Okay, now the solution set. So the solution set is pretty straightforward. It's pretty simple. Basically, right? This is one factor. This is another factor. When you multiply them, they both give you 0, right? So either one of these factors can be 0. Any one of these parentheses can be 0. So they're asking you, okay, what will make this first parentheses equal to 0? To figure that out, you go ahead and separately you set the first factor equal to 0. And we're going to do the same thing with the second factor, x minus 8. Set that equal to 0, and you just solve for both. So it's pretty easy, right? It's pretty nice so far. We're going to go ahead and subtract 7 from both sides. So you get x equals -7 for one solution. And over here, same thing. You're going to add the 8 to both sides so that they can cancel. And you get x is also equal to +8. And we are done. So x is equal to -7 and a +8. So let's go ahead and put this inside of my math lab. So we have -7. You have to put your comma, and let's go ahead and put, oops, it's not a negative. So -7 comma, -8, +8. Sorry about that. All right, that's it. Excellent. All right, let's keep on going. All right, let's go ahead and hit similar. We're going to get it right this time. Anyway, use factoring to solve the quadratic equation. Oh, one thing I didn't specify. It says check by substitution. You know, you can always plug the number back in. Yeah, we can, but I'm so confident in my factoring ability, I know the answer is right. But I tell you what, we'll do it on this one, and we're also going to use the graphing utility that we had the option of using. Anyway, we have 4x squared equals 29x, and then plus 24. And let's see what's going to go on with this one. All right, first things first. You want to bring everything over from one side and bring it to the other side, but to where? Wherever your x squared term is, that's where you want to bring it to. So let's go ahead and subtract this 29x from both sides. And let's go ahead and subtract this 24 from both sides as well. So both of those are gone. And yeah, I wrote it vertically, but you're gonna see it's the same thing. Horizontal, vertical. As long as you do the correct math computations, you can't go wrong. Let's make some room for the equal sign. All right, so we're gonna go ahead and put 4x squared minus 29x minus 24 is equal to 0. So can 4x squared and 29 and 24 be divided by some number? The answer is no, they cannot. But it's not the end of the world. We're gonna go ahead and use a different type of method. You may have heard of the AC method, but this is gonna be a different type of AC method. And here's what you do. This 4 right here is the problem, right? Normally we'll just be able to try to factor it up, you know, make your 2 parentheses like in the last example, but we're going to do something a little bit different. So the name of the method is called the AC method. It's a variation of AC, right? So you're going to need your A and you're going to need your C. So here's what I want you to do. This 4 right here, I want you to take that 4 and multiply it with the 24. So once you do that, you're going to see what I mean. You take off the 4 and put it onto the 24 by multiplying. You're just left with x squared. Nothing happened in the middle term, right? We didn't do anything to the b term. This is going to be 29x. And then we have 4 times 24. Let's go ahead and use our calculator for that, because why not? All right. Yeah, there's the calculator. Okay, and we are doing 4 times 24, 96. So let's go ahead and take off the calculator again. All right, we know that this thing is going to be positive 4 times negative 24 is negative 96. And now we have something a little bit more workable, right? So let's see if this is factorable. And it should be. So as you know, we're going to put our x in front. The signs, the c term here is going to be negative. So whenever you have a negative c term, you want to go ahead and say that's just plus and minus every time. You're going to see every single factoring case where you have your c term as a negative, it's going to be automatically plus and minus. I'm hoping we have one with the plus as our c term so we can adjust ourselves accordingly. But anyway, factors of 96 that when you subtract them gives you negative 29. So let's go ahead and find all of our factors of 96. So we have 96 times 1. That's the very first factor. Is always the factor you're looking for times 1. And let's do our, I call it the dot man method from the last video. Once again, check that video out. Anyway, divide by 2, you get 48. Multiply by 2, you get 2. Divide by 2, you get 24. Multiply by 2, you get 4. Divide by 2, you get 12. Multiply by 2, you get 8. Divide by 2. Multiply by 2. divide by 2, multiply by 2. 3 cannot be broken down anymore, right? So we're going to switch to the other side and do the same as that routine. We're going to divide the 32 by 2, but don't we get 16 when we do that? And the answer is yes. So that's all of the factors. That's all of them. Which one do we need? So remember, we want to find factors of 96 that when you subtract them would give you negative 29. So which one of those would give you a negative 29 when you subtract them? It has to be this guy. 32 and 3, right? Because 32 minus 3 is 29. Yes, it is. So which one goes where? Remember, the bigger number takes the sign. The bigger number is 32. 32 has to be the same sign as the middle term. So we're going to go ahead and put 32 right in there, which means the 3 goes here. Now, we're almost done, I promise. That was just one little elephant in the room, and that was the 4 sitting here. Remember, it started off with the 4 at the beginning. So bear with me here. All we're going to do is take this 4 and we're going to bring it back here, and we're going to bring it back here. If you can remember this, once you take the 4 off with the AC method and bring it back towards the end, you're going to see you're going to breeze through these problems. Like it seems like it's not even mathematical at first, but trust me, this is the method that I use, and I'm not just using it because I'm good at math, but it works like cleanly. And let me show you why. So over here, you're going to have x plus 3 over 4. That's one factor. Is done. Over here, x minus 32 over 4 is going to be 8, right? Doesn't it reduce to 8? And look how clean that is. We got it. Even though we ended up getting a fraction, it all works out. Let's fix that. Anyway, so if you cut on from the last example, basically the answer is just the opposite of what we have here. So x is equal to negative 3 over 4. And the opposite of negative 8 is positive 8. And we're done. So, it's saying to rewrite this in factor form, right? Let's see if they're going to accept that x plus 3 over 4 times that x minus 8. I don't think they're going to accept it, but it's not the end of the world. If they don't accept it, we'll just change it up, change one little thing. It's a little, the method, I'm not going to lie, is just a little unorthodox for them. Mathematically, is legit, okay? But we'll see what they got. We'll see if they accept it. It's saying it's incorrect, but that's fine because I'm going to show you what to do. You see the 4 that's on the bottom here? That's the issue here. So what we're going to do, all you do, right, whenever that happens, whenever you reduce it, take the 4 and put it right in front of the x. Look at that. Mathematically, it's the same exact thing. I don't know why they won't let us be great, but it's whatever. We'll play by the rules, okay? All right, so inside the computation, we're just gonna add a little step here before we start setting things equal to 0. Let's just add one little step for us. Well, for them, really. And who knows? It may help us out in the future. Whenever you have a bottom number, a number on the bottom, your denominator, go ahead and take that denominator and just slap it in front of your x. Mathematically, you're going to get the same exact thing. So, set it equal to 0. You're going to get 4x plus 3 is equal to 0. And you're also going to get x is just negative 8 equals 0. And we should be okay. Just go ahead and solve for them separately. And look, we're going to get negative 3 over 4 again, okay? Subtract the 3, divide by 4. Yeah, I'll do it to not cut too many corners here. So 4x plus 3 is equal to 0. We're going to minus the 3 from both sides. So you get 4x is equal to negative 3. Divide both sides by 4. You're going to get x is equal to negative 3 over 4. And the other solution, you're going to get x is equal to positive 8. Just like we got some, a few minutes ago. All right, anyway, let's go ahead and write negative 3 over 4. And if you want my help on factoring, I'm going to make another video separately, a more extensive video. Right now, the homework is our priority. All right, well done. All right, next, this is question number 3. Let's go ahead and hit similar question for this. And moving right along, let's go ahead and clear this. And what do we have? It says use factoring to solve the quadratic equation again. So same, same deal. I'm gonna go ahead and handle business. So we have 2x squared plus 14x equals 0. Very nice. Everything is already equal to 0. So the only thing we have to do now is just find a GCF. What can 2x squared plus 14x be divided by? 2. How many x's can you take out from both of them? Just 1 x. So you can divide both of them by 2x, basically, right? I also have a video on GCF. You go ahead and check that out. It's very, very, very good. If I do say so myself. Anyway, down the line, we have 2 divided by 2. That gives you a 1, right? We have x squared divided by x. You take an x out, you're just left with x. Keep the sign going, plus 14 divided by 2 is 7, and x divided by x goes away completely. So you're free to close it up. So we have 2x, parentheses, x plus 7. Okay, so now what? Well, since everything is nice and factored up, go ahead and set both of those factors equal to 0 separately and solve separately. Okay, so you know what? It's going to ask us to rewrite the equation in standard form. So before we solve, let's go ahead and write this in factored form. We have 2x on the outside, open parentheses. Oh, we don't need that open parentheses. So 2x, open parentheses, x plus 7. Enter. Bam, there it is. Well done. Okay, the solution set. So let's go back and set those equal to 0 and solve. Now, over here, we're trying to get the x by itself. What's stopping the x from being by itself? The 2 that's in front. To get rid of this 2 that's multiplying with the x, you're going to divide both sides by 2. Remember, the opposite of multiplication is division. So you're left with x is equal to 0 divided by any number is still 0. Right? 0 on top is 0. 0 underneath is undefined. You can't set something on top of nothing. So if you ever get 0 in your denominator, that's a no solution type of deal. Okay, over here, minus 7, x is 7. So x is 0, comma 7. And those are our answers. Haha, -7. Haha. It happens to the best of us. Negative. Let me use my stylus. Negative. All right. Anyway, we're in another question anyway. All right, and it looks like a doozy, but it's okay. Once again, it says solve the equation by factoring. So we have 2x. And the idea, remember, the idea is always to eventually get everything equal to 0. Ah, come on. Oh, it worked out. That's an 8. Okay, so, what do we do here? Well, we can start by distributing this 2x times the x minus 2. So, give me 1 second. Yeah, let's do it. So 2x times x, so this times this is going to give you 2x squared. Now we have 2x times -2, which would give you -4x equals. Not too bad, right? Okay, so our x squared term is over here to the right. So let's bring everything from the left and bring it over to the right. So we're going to subtract the 2x squared from both sides. You know what? This is also an x squared term, right? So I'm going to put it underneath there since they're like terms. And let's cross them out. And we also have the 4x. So I'm going to add it to this other term, 4x. Cross those out. Now, everything here on the left-hand side is crossed out. So we have 0 is equal to, we have 8x squared minus 2x squared. You're going to get 6x squared. Remember, whenever you have the same type of term, the same Like if you have x squared, just subtract the numbers in front. And you're going to keep that x squared. You need the x squared. All right, we have negative 9x plus positive 4x. Negative 9 plus 4 is negative 5. And this is an x term. So now this looks much, much cleaner, right? And word of note, isn't this essentially the same thing as the previous step? 0 is equal to 6x squared minus 5x. So 6x squared minus 5x is equal to 0. So, hey, I don't know why, but for me, I like to see my 0 on the right-hand side. If you don't have that problem, I mean, you can just jump in and handle business. Anyway, we have 6x squared minus 5x equals 0. What's the GCF? What can you divide? What can you divide 6x squared and 5x by? So they both have an x, right? And that's it. We can't divide any numbers. We can't divide them by any GCF because they don't really have a GCF besides 1, which doesn't count. Anyway, let's go ahead and take out an x. Take out an x, you're going to be left with 6x. And then minus 5. Everything is still equal to 0. We're almost done. Everything is nice and factored up. So set both of the factors equal to 0 separately. We have x is equal to 0. And then we have 6x minus 5 is equal to 0. So over here is already done. We get x equals 0. Over here, just a little bit more math. Go ahead and move the 5 over to the other side. So you get 6x is equal to 5. And go ahead and divide both sides by 6. You're left with x is equal to 5 over 6. So your two solutions are x equals 0 and 5 over 6. So is that all they wanted? They said rewrite the equation in factored form. So the factored form of the equation, it would be right before you set them both equal to 0 separately. So the factored form would be right over here. Let's put it in green. And the solution set would be right over here when you do set them equal to 0 and solve, from down here in this step here. All right, let's go ahead and put our answers in. So the factored form, before you set it equal to 0 and start solving, you get x, you're going to get 6x, and then minus 5 is equal to 0. Good job. Solution set, 0, comma, 5 over 6. Good job. Okay, I already did this one, but it's okay. We're going to do it again. Solve the equation by the square root property. So the square root property requires you to take the square root. Keep that in mind. Okay, so we have x minus 8, the whole thing squared, is equal to 9. Okay, so you have a few options here. Now, it wants us to use the square root property. However, if you didn't want to use the square root property, you could potentially, technically, you could just do x minus 8, times x minus 8 equals 9. You're going to distribute, so you get x squared. You're going to distribute, so you get negative. Yeah, you could do that, right? But they want us to use the square root property, and you're going to want to learn to use it because you want to take the most easiest, quickest route, right? So here's what we're going to do. We're going to go ahead. Now, is it safe to take? Is it safe to take the square root of both sides potentially if we wanted to? Well, yes, we have a square term here. If you take the square root of x minus 8, you're just going to get left with the x minus 8. That's good. Is 9 a perfect square? Yes, it is. But you know what? Even if it wasn't, even if 9 was not a perfect square, you still want to take the square root of both sides, and you're going to see later on why that is, because even though it's not perfect, it can still be solvable. Anyway, you just took a square root of x minus 8 squared, so you're just left with x minus 8. It just comes out of the square, the second power. And over here we have the square root of 9. Well, before we figure out that the square root of 9 is 3, before we do that, put a plus and minus, please. You just took a square root of something involving a variable. So in practice, whatever you put on the right hand side, whatever it comes out to, you want to put a plus or minus in front of that something. Okay, so it's very important. What is going on with me today? I'm just making a mess with this. Plus and minus. Okay, and what is the square root of 9? The square root of 9 is 3, so it's a positive 3 and a negative 3, right? Positive 3 squared is 9. Negative 3 quantity squared is also 9. So you need plus or minus. And now the last step we're going to do is go ahead and add 8 to both sides. You have x is equal to, and now when you're writing these side by side, write your term that does not have the plus or minus next to it first. Write that one first. We're going to write the 8 first. Then the plus or minus term, we're going to write right next to it, like second. It doesn't matter which one you write first, but it's just easier on the eyes when the plus or minus term is to the right and you see the plus or minus symbol in the middle. It just aesthetically it looks better. Okay, so we have two different solutions here. We have x is equal to 8 plus 3, and we have x is equal to 8 minus 3. Remember, this is plus or minus, so you have two different combinations here. Okay, let's go ahead and solve this one. X is just equal to 11. And over here we have x is equal to 5. And guess what? We're done. So they didn't ask us to do any factor form because it's already in factor form. They just want the solutions. Let's go ahead and give it to them. 11 and 5. That's it. Fantastic. All right. Yeah, you see what's gonna come up. But don't worry, it's not that bad, I promise. All right, let's go ahead and clear this. Okay, we have, this is question number 6, by the way. All right, so we have 5 x plus 3 whole thing squared is equal to 90. Okay, now, unlike the last example, as you know, in math, they're just going to keep adding things, and you have to know what to do first, right? We can't just go ahead and take the square root of both sides. Mathematically, you technically can, but now would not be the best time because we have a 5 sitting there. And, yeah, that 90 is going to cause just a little issue, but it's not that bad. Before you do the square root property, you want to make sure that you're only taking the square root of something that's being squared. You don't want to take the square root of the 5 as well. So what we're going to do, this is 5 times x plus 3, right? So what we're going to do, we're going to get rid of the 5 that's multiplying with this by dividing by 5. Remember, if multiplication is what's going on, to get rid of multiplication, you want to use division. So divide by 5, you're left with x plus 3 squared is equal to, let's see, 9 divided by 5, that goes in one time. It isn't 0, so we know it's going to be even. All right, so 9 divided by 5 goes in one time. We have 4, 18. Now look at this. This looks like our previous example, right? So let's go ahead and take the square root of both sides. So you just took the square root of something that's being squared. So it just comes out x plus 3. Over here, let's go ahead and start by putting our plus and minus because we just took a square root. With the square root property, you always use a plus and minus. Make sure you have that embedded in your brain. All right, anyway, the square root of 18. Let's go up here and write down the square root of 18 for a second. Now, I have a video on this as well. Let's go ahead and say that this is 9 times 2. This is a square root, so let's go ahead and put a 2 here because the square root says that you need 2 of the same number that when they multiply together will give you the number on the inside. But sadly, we don't have 2 of the same number that would give us 18, but we can break down the 18 as much as we can. Make a factor tree. 9 breaks down into 3 times 3. So take a look at your factors that you just got, 3, 3, and 2. We're going to go ahead and write this in this way. 3 times 3 times 2. That's still 18, right? And this is a square root, so we put a 2 in here. If it was a cube root, we would have put a 3. If it was a fourth root, we would put a 4. Anyway, this is telling you to circle 2 of the same numbers and bring out just one of those numbers. This is the way that I do it. So go ahead and circle 2 of those 3s and bring out one of them. Now, what could you not circle? We couldn't circle the 2 because there's only one of them. We would have needed an extra 2. We need 2 2s, but we only have 1, so just leave it in. Okay, now take a look at this. Let's erase this a little bit. Okay, we have x plus 3 is equal to plus or minus 3 radical 2. So far, so good, right? I hope so, because we're done. Go ahead and subtract that 3 from both sides to get the x by itself. Write the term that does not have the plus or minus right at first. So we have negative 3 plus or minus, sorry, not yet. 3 and then radical 2. And that's it, we're done. So the solution set is going to be x is equal to negative 3 plus, we need the positive version, plus 3 radical 2, comma, negative 3. What's going on with me today? Negative 3. It's pretty late. It's like 3:37 a.m. I'm doing this. All right, minus 3 radical 2. All right, so just very carefully, go ahead and put these answers in. Take your time with it. Square root symbols right here. Then don't forget your comma. So make sure you're hitting the right arrow so you can like navigate in between and out. So I'm hitting the right arrow as much as I can. Make sure I'm out. And then negative 3. Then minus 3 radical 2. Hit enter. Fantastic. All right, next, number 7. I think we're halfway there. I think there were like 14 questions in this. Okay, solve the quadratic equation by the square root property. I think this is going to be, I think it's going to be nice. Might get a fraction, who knows? Wink. Okay, we have 7x plus 8. The whole thing is squared. It's equal to 81. Is it safe to do the square root property? Yeah, you have something squared. This whole binomial here is being squared, so you can square root it. And then you have 81, which is a perfect square. So that's great for us. It's going to be clean. I don't think we're going to have any radicals left over. Or not. Anyway, go ahead and take the square root of both sides. So when you take the square root, it comes out clean. You're left with 7x plus 8. Remember, it comes out of the square, so it's no longer squared, equals, you just take a square root. Whenever you're doing a square root property, put that plus or minus. Now, what's the square root of 81? What times what we give you 81? 9. Okay, so now, be very careful. We're trying to get the x by itself, right? The 7 right here is being multiplied by the x. And we have an 8 that's being added to everything else, the 7x. I want you to get rid of the 8 first because it's, you know, it's further away from the x than the 7 is. The 7 is like right up on it. I want you to get rid of the things that are not necessarily as close to the x as the 7 is. So that goes away. You're left with 7x is equal to negative 8 plus or minus 9. All right, and now we're going to go ahead and divide both sides by 7. Now, you have an option. You can either you can either divide everything by 7, or you can put both of them over 7 like that. I think I prefer it this way, but either way is fine. So what I'm saying is, let's go up here. So right here to where we divided everything by 7, I'm proposing that you can also do them separately like this, negative 8 over 7 plus or minus 9 over 7. Since everything is being divided by 7, you can do it that way. It might be better for you. Oh yeah, when you have imaginary numbers, they force you to write it this way. Or because we don't have any imaginary numbers right now, but they will be coming up, You're left with x is equal to negative 8 plus or minus 9 over 7. You know what? Let's go ahead and erase the minus. We have two different answers, right? The positive version and the negative version. Why not? So negative 8 minus 9 divided by 7. And we can solve separately for those. We have negative 8 plus 9, which is positive 1. So we have 1 over 7 for one answer. And then we have negative 8 minus 9. That's negative 17 divided by 7. And that's it. So looking at the answer that we have over there with the negative 8 plus 7 plus or minus 9 over 7, yeah, that's negative 8 over 7 plus 9 over 7, which is still 1 over 7, right? So it's best to keep them nice and together rather than separate it like that with two different fractions. Just keep it close knit. As you do more, you understand why you make certain decisions in math. Like, so you just want to take the easiest route. All right, good job. All right, similar question. Solve the quadratic equation by completing the square. Completing the square is fun. Fun fact, when I first learned this, I had trouble completing the square. I know, me, right? But then once I got it, I said, hey, it's not that bad. There's just one little formula that you have to commit to memory. And it's this over here. To complete the square, you take your b. So whatever your b term is, you divide it by 2, and then you square it. And that's how you get your new c term. So it's like, how do we apply this? So let's close this off over here like that. Okay, so where do we begin? Well, first of all, let me take you back here. We have x squared plus 8x. And remember, we want to usually set it equal to 0. So we can bring this 33 over, so it's negative 33 is equal to 0. Remember, all we did was subtract 33 from both sides, right? Okay, so it's like, is this factorable? What are the factors of 33? Well, the first factor is always the number you're looking for times 1. And we can use the dot man method, divide by 3, multiply by 3. And this is it. We have 11 and 3, and we have 33 and 1. Oh, when you subtract 11 and 3, you will get an 8, won't you? Okay, we got lucky this time, okay? Even though it's telling us to complete the square, and I'm not going to do it an injustice. We're going to complete the square. But listen, we already have the answers. Go ahead and factor it up. Because this was a nice one. This is a generous one. But that's exactly what they want you to believe. They want you to get comfortable in thinking, oh, I can just go ahead and factor normally like in question number 1. But nah, that's not the case. We have another negative c term, so that's plus or minus. Factors of 33, that will give you an 8. We have 11 times 3. Which one goes where? Remember, the bigger number takes the sign, so the bigger number is 11. And we have 3 here. And look, we have our answers. X is equal to negative 11 and positive 3. Let's go ahead and just put the answers here just for kicks. But I still want to show you how to complete the square with it. Oh, I got it wrong. Maybe we should complete the square. What did I do wrong? We have 11 times 3. Oh, they didn't want us. Reading is fundamental, folks. I was so hyped on just jumping into it. It says to complete the square, what number should be added to both sides of the equation? That's this guy, C. I'm so quick to just jump in. This is your new C term right here. Is the number that must be added to both to complete the square. You need a new C term. So in order to do that, let's go ahead and erase everything for starters. That's why I should always read. But you know what? Let's consider it as practice, I guess. Okay, so we have x squared plus 8x equals 33. Okay, so it's like, what are we going to put for our C term? Well, all you do is apply the formula b over 2 quantity squared, and that's it. So it's like, what is our A, what is our B, what is our C? So remember, the standard form is always ax squared. So ax squared plus bx plus c, right? Now, we don't have a C term here, but it would normally be right up in there. So I tell you what, we're gonna write x squared plus 8x plus a space equals, let's erase this, give some room. Okay, equals a space plus 33. So the number that goes in there, let's just apply the formula, complete the square formula. So you take your b, which is 8, you divide that thing by 2, and you square it. 8 divided by 2 is 4, and then 4 squared is 16. That's it. So 16 is the number that you add to both sides. Remember the rules of algebra, it never goes away. Whatever you do to one side, you do to the other. So that's it. 16 is the number that you add to both sides. And then they're going to ask us to solve it. Okay, so we have 16. Now, what is the solution set? So I might as well show you how to solve once you complete the square, like how to actually go through and solve it. Okay, well, you just went through all this trouble of completing the square. Up here, you have x squared plus 8x plus 16. And this is equal to 49, right? But over here, because you just went through the trouble of completing the square, you have what's called a perfect square binomial. This is a perfect square trinomial, x squared plus 8x plus 16. You just completed the square. You did b over 2 squared. You just made a perfect square trinomial. Every perfect square trinomial, when you factor it, will have a perfect square binomial. So basically, here's what I'm saying. You know x is going to go in front, right? To get the number that goes in here, look at this term right here, right before you rose it to the second power. It was a 4. It was a positive 4. So you're just going to put a positive 4 right there. That's the technique. That's the trick. So now that we have this over here, now we can go ahead and we can use the square root property. Just take the square root of both sides like so. I know it's getting really colorful here, but don't worry. You know, let's cut this off. Okay, so it comes out of the square root. X plus 4 equals, you just take a square root, plus or minus 7. X is equal to negative 4 plus or minus 7. So x is equal to negative 4 plus 7, which is 3. And x is equal to negative 4 minus 7, which is negative 11. That's it. Didn't we already have this? At this like years ago, right? Reading is fundamental. Okay. Question 9. So it says solve the quadratic equation by completing the square. So we have x squared minus 14x minus 8 is equal to 0. Now, they specifically told us to complete the square. So this negative 8 right here is useless to us. We're not going to use it. So we're going to bring it over to the other side by adding it. So whenever they say complete the square, that means that the term that does not have an x in it is useless. Put it on the other side. Minus 14x. And because we're going to be adding a new c term, let's just make room for a space. You see, I have 2 spaces because whatever you find on the left side, you're going to do the same thing to the right. Okay, so remember the formula from a few minutes ago? We take your b term and you square it. Your b term here is 14. You're going to divide that thing by 2 and then square it. So 14 divided by 2 is going to be 7 squared, which you know is 49. So 49 is the number you're going to add on the left. In algebra, whatever you add to your equation on the left, you do the same thing to your right. Now this is a perfect square trinomial. So a perfect square trinomial will have a perfect square binomial, and here's the trick again. So we know it's something square like that. 49 plus 8, 57. Okay, perfect square trinomial turns into a perfect square binomial. X is always going to be in front. So what was your b term? Oh yeah, this is a negative, right? Because it was negative 14. What was your b term before you rose it to the second power? Right before you squared this thing, what's in there? Negative 7. That's it. Put it there. Put it right in there. You can always factor this normally, but you know, we went through the trouble of completing the square, so use every trick that you can, every shortcut that you can use. So whatever's in here, right before you rose it to the second power, just copy and paste that number and put it in there. It works every time, I promise. Okay, so let's go ahead and take the square root of both sides. So over here, we're going to get x minus 7 is equal to, you just took a square root, plus or minus the square root of 57. I'm not sure if the square root of 57 can be broken down, but you know what? We're going to try. So we have, let's put the square root of 57 right over here. I see that it's 3 shy of 60. Let's do our little 3 trick from one of my previous videos. If you add 5 plus 7, will that result be divisible by 3? Well, what's 5 plus 7? 5 plus 7 is 12. Is 12 divisible by 3? Yes. So 57 is divisible by 3. So you know what? Let's just go up here and figure out what 57 divided by 3 is. Goes in 1 time, so minus 3. We have 2, 7, 9. Yeah, that's a no-go. You're going to get 3 times 19. 19 cannot be broken down. So this thing is going to stay at 57. Remember, we're not going to have 2 of anything in here. So we don't have to take the radical. We don't have to try to break it down. Okay, but the good news for us is that now we're done, basically. So we have x is equal to 7 plus or minus the square root of 57. But before we jump the gun, it says to complete the square, what number should be added? What did we add? We added 2 49s. So 49 must be added to both sides. Good job. Now, what is the solution set? It's right down here. We have 2 different answers. We have x is equal to 7 plus the square root of 57 and 7 minus the square root of 57. And that's it. So 7 plus square root of 57. Move the right arrow. I should say move with the right arrow. 7 minus square root 57. Well done. I took my time and wrote up the quadratic formula for you guys. Yeah, it's the granddaddy of all the formulas. Basically, if you commit this formula to memory, if you can get everything equal to 0, you can use this formula to solve for all of your quadratic equations. That's the trade-off. So you take your time to memorize this formula, negative b plus or minus big old square root b squared minus 4 times a times c divided by 2a, and you can solve anything. The only thing is that it's a little bit time consuming, but if you're quick and if you do it correctly, you can't go wrong. But anyway, first and foremost, so you know that standard form is written like this: ax squared plus bx and then plus c, right? I'm writing it in capital. This is the standard form of a quadratic equation, and you want to figure out what your a, your b, and your c's are, and it's always the number that's in front of the x is the coefficient. Okay, so you do not include the x inside of your computations inside the formula. Okay, so let's go ahead and take the number we have here, 10x squared, and we have negatives. Let's go ahead and bring everything over to the left hand side. Equals 0. So we took the 6x, we brought it over, and we also brought over the 3. So now take a look here. Your A term is here. Your B term is here. Your C term is here. So just to be really nice and neat, I'm going to go ahead and write down that our A term is equal to positive 10. Our B term is equal to negative 6. And our C term is equal to negative 3. So all you do is apply this to your formula and we're good. Now, the worst case scenario is that we have a pretty big number inside the radical, but it's okay. They're always solvable. Okay, so let's go ahead and start plugging some stuff in. So we have x is equal to negative b. So we have negative. Let's use a parenthesis so that we know to distribute later. So negative b, your b is negative 6, plus or minus big old square root. We have b squared, which is negative 6 squared, minus your 4 times your a times your c, all divided by 2 times your a. Your a is 10. I know it looks horrible, but don't worry, we're going to get through it. It's easier than it looks. What I like to do, let's go ahead and take a look at this minus 4ac portion. You know, we have negative 4 times 10, which you know is negative 40, right? And then we have negative 40 times negative 3, and we get negative 120. So I always want to look at that term over there because there, you know, there's a possibility that it could be negative, which means we're going to have an imaginary number. But that's not this case because we know a negative 4 times 10 times negative 3 is still positive at the end of the day. So you always want to, you know, look ahead and see if you're going to have some funny business going on later. Because a negative underneath the radical means that it's imaginary, right? They call them complex numbers, I believe. So we have 6 squared, which is 36, plus this is negative 4 times 10, which is negative 40. Negative 40 times negative 3 is positive 120. And everything is over 2 times 10 is 20. And now this is going to be 6 plus or minus the square root of 36 plus 120 is 156. And this is all over 20. So let's go ahead and see if we can break down 156 like up here somewhere. So very simply, this is a square root, so make sure you put a 2 here. We can divide this thing by 2, right? We get 78. We can divide 78 by 2. You get 39. 39 can be broken down into 3 times 13. And you know what? We're going to do that. Let's do it. Why not? A little too close. Okay, the square root, because we put a 2 here, that's what square root is all about. A square root says that you take 2 of the same number and you leave in whatever couldn't be broken down. So we have 2 2s here, so bring them out. What can't you circle? You can't circle the 13 and the 3. So because you can't circle them, they just turn right back into 39 when you multiply them again. So that's going to stay at 39. And that's what we get over here. We're going to get 6 plus or minus the square root, 2 times the square root of 39 all over 20. Let me make sure you guys can even see this. No, you cannot see it. All right, but it's over 20, okay? I'm going to bring it down here. Okay, where are we? Okay. So look, we're going to have 6 plus or minus 2 square root of 39 divided by 20. And you can clean it up just a little bit. Now, the 6, the 2, and the 20 can all be divided by 2, right? So think of it as like a little triangle or something. Like if it's something like this, I don't know. You just want to focus on those 3 whole numbers that are there. So let's just divide it by 2. You're going to get x is equal to 3 plus or minus 2 divided by 2 is 1. You're left with the 39. And this is all over 20 divided by 2 is 10. So this is your solution. 3 plus or minus the square root of 39 over 10. So let's go ahead and put that crazy number in. All right, so we have 3. Oh, and we have a fraction. So whenever you have a fraction, type in your fraction button first. So we have 3 plus the square root of 39. We're divided by 10. So that's the positive version, right? So comma, we're also going to have a negative version. Go ahead and put your fraction again. We have 3 minus the square root of 39. And then all over 10. Excellent. Okay, so it says solve the equation by the method of your choice. So let's just jump right in. So anything that you've learned so far, you can use completing the square. Don't use completing the square. You can use quadratic formula. Don't use that either. I'm going to go ahead and bring this 21 over to the left just so I can set it equal to 0. Minus 21. Okay, and I'm going to use that fancy AC method I showed you guys a little while ago. It involves the 2. So we're going to take this 2 off. And we're actually going to multiply it with this 21 over here. And don't forget that we're going to bring back that 2. So the leading A term, we have A and B and C, right? The leading A term is going to do some things that we have to, stay on top of. But anyway, you take off the 2, that becomes x squared. Nothing happened to your B term, your middle term, so leave that as negative 11x. And then we're going to take the 2 and multiply by the 21. Remember, this is called the AC method. It's a type of AC method. So 2 times 21 will give you negative 42. And now we're going to go ahead and just factor this up. So, x goes in front. We have a negative in the back. Sorry, excuse me. We have a negative in the back. And so automatically that's positive and negative. I think we had negatives each and every time so far. Okay, let's see what else is next. Factors of 42. The C term is negative. So factors of 42 that when you subtract them gives you negative 11. So over here, divide by 2, multiply by 2, divide by 3, multiply by 3. And that can't be broken down anymore. So we're going to switch over to the 6, divide by 2, multiply by 2, 14. Which one do we need? 14 and 3 will give you an 11, right? So we're going to use 14 times 3 as our factors. Now, which one goes where? The bigger number takes the sign, so make sure you put 14 here and 3 here. Remember, I told you that that 2 is coming back. So it comes back this way. You divide this by 2, and you divide that by 2. That comes from here, right? So I guess we can put it in blue. So it's like, now what? Well, we're going to have, 3 can't go in a 2. So here's how we're going to do it. We're just going to take the 2 that's on the bottom and put it in front of the x. Just cut and paste. Over here, 14 can be divided by 2. You get negative 7. So here are your factor versions. We're going to have 2x plus 3 is equal to 0. Subtract 3 from both sides, you get 2x is equal to negative 3. Divide both sides by 2, you get x is equal to negative 3 over 2. And over here, you just get x equals 7. And we are done. So let's see, we have negative 3 over 2. And we have 7. All right, next, similar question. All right, method of our choice again. Now, just by looking at this, we won't be able to do the AC method. Because if we bring that 1 over, like so, there are no factors of 1 that would give you an 8. So you know what? We're just going to leave that 1 right where it's at. So our C term here is useless. So remember, whenever your C term is useless, you're going to use the complete the square method. Why not? So we're going to leave that 1 right over here. And we're going to put some spaces down. It's going to be adding something over here and adding something over here. So what do we add? Well, you have to follow the little formula that says you take your B, you divide by 2. I can do better than that. Okay, you take your B, you divide by 2, and then you raise the whole thing to the second power. So what is your B? Your B is 8. You divide by 2, and you square it. 8 divided by 2 is 4. Square it, so you get 16. That's what you're going to add here. Whatever you do to one side, you do to the other side. Let's go ahead and you just went through the trouble of completing the square here. So that's a perfect square trinomial, which turns into a perfect square binomial. This is 17 over here on the right. So you know x goes in front. Now, what was your B term divided by 2? It was down here right before you squared it. You get a 4. That's the trick. Now we're here. Let's go ahead and take the square root of both sides. We're using the square root property, which means that we're going to have a plus or minus. There is no square root of 17. Just leave it just like that. Last thing, go ahead and minus the 4 from both sides. That goes away. You get x is equal to -4 plus or minus the square root of 17. So remember, you have two answers, right? A positive version and a negative version. So we have -4 plus, what's going on? All right, -4 plus the square root of 17, comma, -4 minus the square root of 17. All done. It's similar. All right. We have things wrapped up in parentheses over here. So we're going to have to do a little distribution. All right, 5x plus 1, x plus 2 equals -1. All right, first things first, let's go ahead and distribute. We have 5x times x, which is 5x squared, 5x times 2, which is 10x, 1 times x, which is 1x, then 1 times 2 is 2. Very nice, right? Let's go ahead and bring this one over to your, let's combine like terms. These are your like terms. We have 5x squared, and then we have plus 11x, and then we're going to add 1 to both sides, and we get a plus 3. So I'm tempted to use the AC method here again. Why not? So we're using the AC method. So remember, we're going to take this 5. We're going to multiply with whatever your C term is first, and then we're going to bring it back. Okay. So let's go ahead and set it up. Take off the 5, x squared, plus, leave the middle the same, 11x. 5 times 3, 15. Clean. Now it's factorable. Well, it looks factorable. We're going to find out in like 2 seconds. If it's not, we'll just do the quadratic formula or something. But anyway, factors of 15. The first factor of 15 is 15 times 1. Let's find the factors. Divide by 3, multiply by 3. None of those factors. 15 and 1 will never give us an 11, and 3 and 5 will never give us an 11. So we cannot factor this. Looks like we're going to have to complete the square, or better yet, let's use the quadratic formula. The quadratic formula never fails, ever. So I'm just going to write down this. Let me write down what we had. 1 second. So we have 5 x squared plus 11x plus 3 equals 0. Yeah, I'm going to use the quadratic formula on this. Let me erase everything. And you know, sometimes it's like that. Like I wasn't sure exactly what it was going to be before I started. But fear not, go ahead and distribute, get everything equal to 0, and then go ahead and apply the quadratic formula. So the quadratic formula says you take your x is equal to your negative b, which in this case is 11, plus and minus big old square root. And then you're going to take your b squared minus 4 times your a times your c. You divide all of that by 2 times whatever your a is. Remember, I'm getting all of that from here. This is your a, this is your b, and this is your c, and that c is a 3, not a 5. Where did I get 5 from? Oh, yes, a is 5. I'm good. I'm right. I'm correct. Anyway, let's keep going. All right, so we have x is equal to negative 11 plus or minus big O square root. 11 squared is 121. This is negative 4 times 5, which is negative 20. Negative 20 times 3 is negative 60. This is all over 2 times 5 is 10. X is now equal to negative 11 plus or minus square root. 121 minus 60 would be 61, right? All over 10. And as far as I know, 61 is not a part of any time tables that I know. So we are done. So let's go ahead and put negative 11. Oh, well, it's a fraction. We have 2 fractions. So negative 11 plus the square root of 61. (10), comma, another fraction. So if you stick with this, that quadratic formula, you can't go wrong no matter what. There's no second guessing. There's no trial and error type stuff going on. Okay, so in this last example, you can see we have parentheses 3x minus 5 squared equals 25. I already got the points for this one, so I will just explain how I did it. All right, so it says method of your choice. So you can see that on the left side, we have a binomial squared, and on the right side, we have a perfect square. 25 is a perfect square, right? This problem right here is just screaming for us to use the square root property. So go ahead and put 3x minus 5 squared is equal to 25. Let's go ahead and start off by taking the square root of both sides. So we're going to square root the left, and we're also going to square root the right. So this is going to give us 3x minus 5 is equal to 5. You just took a square root. Make sure you put your plus and minus. Okay, go ahead and add the 5 to both sides. And so we have 3x is equal to 5 plus and minus 5. And lastly, go ahead and divide everything by 3. And so we have x is equal to 5 plus 5 divided by 3. And 5 minus 5 divided by 3. So 5 plus 5 is 10. So we have 10 over 3 as one of our answers. You can see it there. And then we have 5 minus 5, which is 0. 0 divided by 3 is 0. And that's how we get the solution.